Now you know we've gone over this confidence interval thing, and as with many things in statistics, there is a shortcut on your calculator. And I'm going to show you the shortcut for the TI-84 since that's what we have in the classroom. So on the TI-84, it's called the one prop Z interval. So you're going to press stat and go to tests, just like we've been doing. Well, this is new. We haven't really been using tests too much. And then you're going to scroll to A, which is the one prop Z interval right there. Once you select that, you're prompted for X, which is the count that meets the criteria. This is your successes. N is your sample size, and C level is your confidence level in decimal, not percent form. And then once you do that, the calculation, you have this, and that actually shows the low end of your interval and the high end of your interval. So if you saw in that previous example, this should be very close to the two numbers we had. It also shows you your p hat, which is the proportion from the sample and the sample size. Let's go ahead and do another example, this one with a new medication. So an experiment finds that 27% of 53 subjects report improvement after using a new medicine. Create a 95% confidence interval for the actual cure rate. Why is this interval so wide? So first of all, let's just focus on the interval. Well, we're going to start with state, which is we're trying to do a 95% confidence interval for P equals, the parameter equals the true proportion of subjects that improve after using a new medicine. So we really want to know how many really do improve. And we're just going to do an interval because we won't know exactly. Then is the plan. So what method will we use? Well, you've only learned one, the one sample Z interval. And we can use that once we show the conditions are satisfied for normal model. All right. First condition, we have to check the random condition. Well, they didn't tell me if they took a random sample. So you can say, hopefully the experiment included random assignment of volunteers to treatment groups. By the way, this is an experiment, so it should be random assignment. So we're making that assumption before we move on. 10% condition. Well, we're not really worried about replacement. In this instance, it's not like we're using up the medication completely. We can always make more. So we don't have to worry about the 10% condition. Sometimes you might see like archery examples where they keep shooting at targets. You don't use up all the attempts. It's not a replacement issue. Large counts. Well, our successes are 27% of 53, that's 14. That's greater than or equal to 10. And I could say 53 minus 14 is 39, or I could do the Q there. But that's also greater than or equal to 10. So all three of our conditions are satisfied. Now we're going to go ahead and do the calculation. Remember, you will see this on your math chart, so that will be our inspiration. Let's go ahead and calculate p hat. Well, we know p hat is 0.27, and our sample size is 53. Now I'm going to rewrite this for standard error, and I have q hat here instead of 1 minus p hat, but it works the same. And substitute in the 0.27. The 0.73 I get from taking 1 minus 0.27, just like we have over here. Divide that by your sample size, 53, and you get about 0.061. Now we need to calculate the margin of error, which is your critical value times your standard error. 95% confidence interval, do you remember what this critical value is? Again, we're going to use it all the time. It's 1.96. And we'll multiply that by that number right there, and we get 0.12. So our confidence interval is our statistic plus or minus our margin of error. 0.27 plus or minus 0.12. When I go ahead and do the mechanics there, the math, I get 0.15 to 0.39. So why is this interval so wide? And if you think about it, what did we have about, let's see, let me go to the previous one. We're going to cut it. Try that again. We're going to do cut here in just a second. Previous 15 to 39%. So why is this interval so wide from 0.15 to 0.39? That's 15% to 39%. That seems like a pretty wide window for guessing. Well, the interval is wide because the sample size of 53, that's not a great deal of accuracy. So the bigger we can make that bottom number on the standard deviation, the tighter we can make our window. So that means because the sample size of 53, our standard deviation, really our standard error, is still quite large. Also, since we're using a 95% confidence level, we kind of give up on precision. If we went to, say, a 90% confidence level, then you'd have a smaller window. In fact, let's go ahead and try that. So p hat is still the same. Still have the standard error is still the same because my sample size is not changing. The only thing I'm changing is my confidence level. So this calculation is important. For a 90% confidence level, since we haven't used that, we do inverse norm of 1 minus 0.9 over 2. Again, remember, the middle is 90%. So how much does that leave for the outsides? 10%. And when we do our critical value, it's only the left one. So what's left for the left one? It's going to be 5%. So we do inverse norm of 0.05, which is 1.645. Then we calculate the margin of error just like we did. So instead of 1.96 here, I have 1.645 times my standard of error from before, and I get 0.10. Now I have 17 to 37%. So yeah, I tighten it up a little bit, but honestly, I don't know if I tighten it up that much with a 90% confidence interval. I did, it's a little more precise, but we're also less confident in our ability to capture the true proportion.